4-2, day 2. If you haven't done day 1 yet, you're on the wrong video. So this is day 2. Okay, so we are still working with our product rule that we learned yesterday, which is when you have a product of two functions, the derivative is the derivative of the first function times the second plus the first times the derivative of the second. And you recognize it as an x term times an x term. Our first example is the function f of x minus 7 to the 4th times the quantity 2x plus 3 to the 5th. And we want to do 3 things. Sketch it. Find the derivative. And find the zero of the derivative algebraically. No graph can calculate zero. I spelled that right. So we'll find them algebraically. And the factoring is what's going to do that for us. All right, the sketch, I already took the time. I know you just fast forward through it. So the sketch looks like this. Okay. So let's go for derivative next. F prime of x. So I've got an x term times another x term. That's the product rule. I need the derivative of the first term, so you pretend that's not even there. Start from the outside with the 4. 4 comes down. Inside never changes. Reduce the power by 1, and now times the derivative of the inside. Derivative of 5x is 5. Derivative of minus 7 is 0. I don't need it. Now I still have to multiply by the whole z term without changing it. So all of this was the u prime. This is my v. Continue on. I keep the u the same. 5x minus 7 to the 4th. And now the v prime, you've got your outside here and your inside. So the 5 comes down. Got it. Times the inside. So 1 less power. And then the derivative of the inside is just the 2. So we've got the 2 baskets that we're going to simplify and then we're going to factor. So I've got a 20. 5x minus 7 cubed. And 2x plus 3. 2x plus 3 to the 5th. Over here I can pull out a 10 in front. 5x minus 7 to the 4th. 2x plus 3 to the 4th. Okay, remember, factoring is next. Got a basket here. It has a 20. 3 of these quantities and 5 of these. This basket has a 10. 4 of these quantities, 4 of these quantities. Oh, should that have 12? So here we go. Okay, baskets. I got a 20 and a 10. I can take out a 10. Got 3 of these and 4 of them here, so I can take out 3 of them. Got 5 of these and 4 of these, so I can take out 4 of them. Now I like to put the square brackets, and then I'm just going to say what's left in each of the 2 baskets. So in the first basket, I had a 20. I divided on 10. It's a 2. All 3 of these got taken out. There's none left in here. I had 5. I took out 4. I got 1 of these quantities. Plus, I had 10. Took it out. 4 of these. Took out 3 of them. That leaves 1 of them. 4 of these, but I took all 4 out, and that's it. Now all I have to do is combine within the two baskets by distributing and getting rid of parentheses. And 9x minus 7 cubed, 2x plus 3 to the fourth, we'll do a 4x plus 6, distributing a 1 here, plus 5x minus 7, 9x minus 1. Okay, plus this stuff here. Okay, what I want to do is find the zeros of this function for part C. And I want to do that algebraically. Well, to set that equal to 0 and solve, because it's in factored form, it's very easy. So I've got 10 times this quantity times this. If any one of these quantities equals 0, the whole function equals 0. So that means I want to know what's going to make each one of these equal 0 separately. So I'm going to have 3 spots where this graph actually crosses the x-axis. And that kind of makes sense if you think about the max and min. There's a little, there's a min here, just doesn't show up very well. On the original function, and every max and min on this gives me a 0 on the derivative. So I'm going to find those zeros right here. So 5x minus 7 equals 0. If I solve that, I'm going to add 7, divide by 5. So at 7/5, I've got a 0. 2x plus 3 could equal 0. If I subtract 3, divide by 2. Negative 3 halves, that's negative 1.5. And then I've got 9x minus 1 equals 0. Add 1, divide by 9. 1/9. So you can see this must have been my 1/9. This is my 7/5, and this is my negative 1.5. Okay, we've got on that one. We can use this product rule in other situations besides just an x term times an x term. It's possible that you could have 3 x terms multiplied out. You'd have a u times a v times a w. Well, it's still a product rule, and the way the product rule works with 3 terms is you take the derivative of the first one and multiply by the other 2 just as they are. And you add to that, you take the derivative of the middle one and keep the first and third the same. So it's u times v prime times w. And then, I think you know where it's going, we still need the derivative of the last term times the first 2. So we keep u, we keep v, derivative of the third term. That's just the way the product rule works. If we had 4 terms in here, it would just be one gets the derivative times the other 3. And each one takes its turn having a derivative times the other 3. You'd have 4 parts to it. That's all the product rule is. So let's just a little bit longer, a little more algebra, a little more room for mistakes, so be careful. So y equals x squared times 9x plus 5 to the third times the cosine of 5x. Okay, you have to recognize this as a product rule with 3 terms. This x term, and this x term. So derivative, we're going to go, here's my u. Here's the derivative of this term, that's 2x. The other 2 x's stay exactly the same, so don't change it. Okay, now I keep the first one the same. Doing the derivative of the second one, this is an inside, outside, so it's a chain rule. So I start on the outside with the 3. 3 comes down. Inside never changes. Just reduce the power by 1. And now I do the derivative of the inside, which is just going to be a 9. So I don't need parentheses, so that's going to be a 0. And then I still have to multiply by that. plus, because I've got the three terms, I've got the three parts here, I can fit it all in one line. I'll go right here. Keep the first two the same. And now I need the derivative of the third one. And the third one's a trig function that has its own outside and inside. So the derivative of cosine goes to negative sine of the original angle. Don't change it. And then the inside derivative is the derivative of the angle. Derivative of 5x is 5. So all of that is there. Now, we don't factor when there's a trig function with some non-trig. So we're just going to simplify and bring out to the front anything that needs to come to the front. So this first term, nothing's going to change. 2x, 9x plus 5 cubed, cosine 5x. Here we've got a 9, this is in the middle basket, a 9 and a 3, that's 27x squared. Then we have 9x plus 5 squared, cosine 5x. And in the last one, we got a negative 1 and a 5 that are going to come to the front. So minus 5x squared, 9x plus 5 cubed, sine 5x. I don't think we need another one of those. I think we're going to be fine with that. Just take your time. Make sure you've got all the parts. Boy, do we need to do a four-term one? I don't know. See if four-term one. X to the fifth. 3x minus 1 squared. Cosine 2x. Sine 3x. Couple trig functions, couple non-trig functions. So again, four terms, product rule. So it's the derivative of this one times the other three. Derivative of the middle one times the other three. Derivative of the third one times the other three. And derivative of the fourth one. So you're going to have four baskets on this problem. And then you write small. Start here. 5x to the fourth times everything else. Plus, now I'm going to do the derivative of the middle one when I get to it. So keep the first one the same. Derivative here is a chain rule, like on the inside and outside. So I'm starting with a 2. This one's down. Quantity 3x minus 1 to the first, not needed. And then times the derivative of the inside, derivative there is just a 3. And then times the other 2. 2x. Plus, oh, I like this one. We're going to do the derivative when we get to the third one. So we're going to keep x to the fifth, 3x minus 1 squared. Now derivative here, trig function, angle. Derivative of cosine is negative sine, 2x. Now derivative of the angle is 2. And then sine 3x. Plus, now the fourth one. So I do the derivative when I get down there. X to the fifth, 3x minus 1 squared, cosine 2x. And derivative here, derivative of sine is cosine.